we go. So let's take a look at this in I'm going to pick this nice little blue here. So this is number 7. All right, and I said, like I said, after we're done with this, we can take a quick break, but we won't be here much longer anyway. So it says a rectangle has one corner in quadrant 1 on the graph of y equals 16 minus x squared, and another at the origin, a third on the positive y-axis, and the fourth on the positive x-axis. See the figure. So here is my graph, and I have a couple of points here and here. There's a 4, 1, 2, 3, 4, but I think they scale it differently, don't they? This is 8 and this is 16, and then they have this graph that's a parabola that kind of starts like this, ends here, so it looks like that, and then inside they just kind of draw a thing that looks like this, okay? And here's the rectangle. So they don't really tell you where the 16 minus x squared comes from. It's just there. And that's what I was thinking that it would be, if you could apply it to something and you could say, okay, at least I know what that represents. They don't. That's kind of what these problems are sort of like. So anyway, they put an xy here, okay? And I think I got everything pretty labeled out. It says express the area of the rectangle as a function of x. So this down here is your x, right? Because that's your x coordinate, okay? And the area of a rectangle. Now everybody knows that, pretty much anyway. What's the area of a rectangle?
Base times height.
Yeah, base times height, right? Base times height, length times width, however you want to think of it. Yeah, good job. Length times width, base times height, whatever you want. So then if the base, say, is down here at the bottom, then that area would definitely be an x there, okay? So the height is the other thing that we're not really sure about. But if we look at this and we think, wait a minute, there's my height, right? Well, that's just your y coordinates. So I'm going to put that in there for now. The only problem is that the question says, express the area of the rectangle as a function of x, which means you can't have a y in there. You can only have an x. The good news is they said that y was equal to 16 minus x squared. So I'm going to put an x here, and then in parentheses, I'm going to put a 16 minus x squared like that. And then I'm going to stop for a second in case you're kind of writing this down or you're looking at it. All right, so you can see kind of what's going on. I don't want to go too fast. Okay, so the answer to A here, and they probably would like it if we wrote it in terms of a function. So then we go x times 16 minus x squared. All right, so there's my answer. There's my area as a function of x. So now it says, oh, what's the domain of that? Oh, okay. Well, we could graph it in Desmos, right? See what it looks like. So let's go ahead and let's take a look at that. So I'm going to go into Desmos here. And of course, I got to make sure you can see it. There we go. And put it on this guy here. All right, so here I go. Now I'm just going to type it as y equals x times 16 minus x squared, because that's what it is. All right, so then I have this function here. I'm going to try to get a better, I think I'm going to try to get a better window, but I'm going to use the settings on this thing. So now let's talk about this for a second. So x represents the base, right? So what would be the smallest x we would need on our graph if x represents the base?
Zero.
Yeah, 0, right? Because you can't have a negative length, right? That's impossible. So let's put a 0 there. All right. Now, as far as the maximum over here, all right. Now I had let's say 2 for the smallest. Okay, that's good thinking. Now let's look at that, what you're thinking kind of, I believe, for the largest number, right? So if my base, according to the picture, the smallest is 0, what would the largest possible rectangle be on the base?
4.
4. Yeah, good. So I'm just going to make it a little bit bigger and put a 5 in there. Now my y, it's the same darn thing, right? Because that's the area. And what's the smallest area we could possibly have?
0.
0. Right? I mean, we can't really have a negative area. Okay. And I guess I could have I don't really know much about my area. So I'm just going to put in 20. All right. And if it's not big enough, I'll change it. Now I can see already it's not big enough. So I'll try 40. And there we go. That's not too bad. So here, now I have this graph. All right. And I can take a look at it. I can change it around just a little bit to see what it looks like. Interesting. So this is the area, right? So here's the area. It kind of goes up, maxes out, and then comes back down. But it's only between 0 and 2, or 0 and 4. So we just kind of answered our question. What's our domain between?
0 and 4.
0 and 4, right? Okay. So we kind of answered our question when we were setting up the window. Right? Because in some situations, when you're graphing stuff, everything we've always done pretty much has been just looking at the whole thing, right? Is it all real numbers, or is there something, maybe a point that doesn't exist? Is it a square root where it's only positives? Okay, but in this case, it's tied to a situation, so you kind of want to think, okay, wait a minute, what does x represent in this? Does it represent a distance? Because then it can't be negative. Another one that can't be negative is time. I always say, hey, this isn't Back to the Future. We're not going backwards, okay? Time can't be negative. We have no time machines yet, so we can't do that. So time's got to be positive. So that's kind of what you're looking at. So anyway, we answered that question. So our domain has got to be positive. Then it says graph a of x, and for what value of x is a the largest? Well, we did graph it. How about that? So let's go up here to the largest, click on that, and I see that at 2.3, I get the largest value for my area at 24.6. Okay. So yeah, that was kind of a good idea to graph that, because we got the answers just by looking at it. So I'm going to come down to here, go back to my share of my OneNote here, and put that down. So B, my domain, all right, was 0, 4. Now, you could argue, well, your base really can't be 0, right? And I would kind of agree with that. So I guess you could put some parentheses around that instead of brackets. Um, theoretically, mathematically, it would be. I wouldn't have a problem with saying, 0 to 4 is good. So I think you could probably get away with using either symbol there. Um, it kind of depends on the context, right? I mean, if we're looking at it theoretically, we'd say, wait a minute, we can't have a rectangle with a base of 0. That doesn't make any sense. I don't care what notation you use to write your domain. I really don't. And it's just like I've said in the past, it seems like you got the Math 111 students real comfortable with interval notation. So that's kind of what I use. But you can write it out however that you want and that you're comfortable with expressing your idea there. So C, what was A was the largest? I think it was 2.3 something. Let me go back. Yeah, 2.309. We'll just say 2.3 was the largest x. Okay, gave us the largest value. It wasn't the largest x. It gave us the largest value. Okay, and you could put the point down. Again, I like to do the point 24.6 because I think that a maximum is actually a point rather than a value. All right, so that way you get both, not only what it is, but when it occurred or for what value it occurred at. So, yeah, there are 7. So you can kind of see a little bit of what these are like. All right. So here's the situation. We got 710, right? I'm going to do one more problem out of here. And then that's going to be it for what I'm going to show you lesson-wise. It would be our quiz after that. Why don't we FOIL for A? You can. You can. I just didn't. That's up to you. All right. Anyhow, so if you want, if you think we need a break, let's take one. But what I guess is what I'm communicating to you is I'm only gonna, probably go to about, I'd probably have another 15 minutes or so, and then we take the quiz where you could, jump in and out if you needed to break too. So I don't know what you guys want to do. So throw some ideas in the chat, and I'll just figure out what you want. I got one keep going here. Okay. Keep it going. I'm getting some resounding keeping going. Okay. All right. If somebody does have to do something, you can always feel free to do that. All right. So let's take a look at, again, let me go ahead and stop this here. Oh, it's over here. That's why. Oh, maybe it's here. Oops. I'm going to stop the share. There we go. And come back over to here. And here. And here we go. All right. So then what we'll do is take a look at number 20. Let's see. Where's it at? Oh, here it is. 21. So let's take a look at 21. All right. They talk about inscribing a cylinder in a cone. All right. So here's what we have. So we have, it says inscribe a right circular cylinder of height h. So here's the cylinder inside. All right. And the height of the cylinder is h. Here, let me see if I can annotate a little bit so you see what I'm talking about. So the height is h. That's this. That's the height of the cylinder. Okay. And a radius of r. So here's the radius. They use a little r for that. So we have a little h, little r. That's our cylinder. It's in a cone of fixed radius, which means that this isn't going to change. Okay, and a fixed height, which means this isn't going to change. See the illustration. Express the volume of the cylinder as a function of little r. Okay. Hint, volume equals pi r squared h. So again, I'm going to switch to OneNote to do this because otherwise I don't write very well with the mouse. So if you can't see it, take a picture of it so you can refer to it. All right. I'll clear my drawings for you. And then we'll switch to OneNote here. I think there's more to this up here. Or no, that's it. Okay, so I'm going to stop this share. Drop back over to here. Going to here, I think somebody just chatted with me. Yeah, it is getting recorded. Okay, I want to get this guy out of the way here. Oh gosh. Anyway, I think hang on. There we go. I lost the chat here for a second. There, it's back. Okay. So back on to what we were doing. So let's go on to 21. Okay, so here's the deal. I have a cone, right, like this. Okay, and there's a cylinder that's inside of it, sort of like this. And this is not very drawn very well, but the radius here is r. The radius of the cone is a big R. The height of the cone is a big H. And the height of the cylinder is a little h. So what they want us to do is express the volume of the cylinder as a function of r, right? And it says the volume of a cylinder is pi r squared h. So then what we want to do is we can't have an h there, right? It's got to be r only. So we have to find something that we can do to get it to be, we can get rid of that h, all right? And we can only get in terms of r. So they also have a note that says, if you divide by h, you're going to get v over h. So they don't want h there at all. They only want it to be in terms of r, okay? So I see what you're thinking there, but they only want it in terms of r. So the other thing that they mention is note also similar triangles. Okay, well, what do they mean by that? Well, there are some similar triangles here where we have this R here and this coming down this H. Okay, let me see if I can, I'd rather draw it this way. So here is one of the triangles where this is a little R and this is an H. Okay. And this is the bigger triangle, which is from the cone's radius to the cone's height, and this guy. All right. So these triangles are similar. Now again, this is probably something that you wouldn't have really been able to see. You probably would have scratched your head and said, what are they talking about? That's why I'm going over this. So when you have similar triangles, you can write this little proportion. So if we put little h over big H is equal to little r over big R. Now you might want to, where's this going? But remember that big R and big H are fixed. So that means that they're numbers. They just didn't give you the numbers. So they could be like 10 and 20 or 8 and 12. Okay, they're constants. They're not going to change. So that's what they mean by that. I'm going to do a little cross multiplying here. And remember, what we want to do is try to get this by itself. So now we're going to divide by big R. So H is equal to little r, big H, over big R. So this is actually some number. All right? It's just that it says it's fixed and it's not telling us what the number is. All right. So now what I'm going to do is take this v and go pi r squared times big H, r I should say, big H over big R. Okay, and there's my volume. Okay, so it's kind of a, I mean, it's, yeah, you can kind of see why we're doing these, because it's a little crazy looking stuff. All right, and this is just if we took, because you can move that inside, right? We could have pi times r cubed. So this is the FOIL that you were asking about. Can we FOIL it? And that would be what it would look like. Again, H and R are constants. They're fixed, was what the term that they used. So it doesn't look very clean, but if we knew what those numbers were, it would be. All right? And that's what they're looking for in 21. They don't really have you do anything else with it. That's what they have you do. So 25. Man, having troubles here tonight. Trying to get things moving out of the way. 25 is kind of in the same way. Oh, it can't be 25. Is it? Oh, it is. Oh, this is an open box problem. Okay. I thought I had a different one. I think it was supposed to be 20. I think 20 and 25 got mixed up. So we'll probably change that to 20. Okay. I don't know how I did that, but I'm pretty sure I've always given out 20, because 20 is a little bit more like 21. So we'll change 25 to 20, and I'll change it in the assignment thing, so that you know. But that's what these look. So that's what these are. Okay. And again, they're so beefy that putting them on a test would not be a good idea. And they're kind of, I mean, they don't really give you an idea of why you would put a cylinder inside of a cone, right? Where at least the GeoGebra one kind of had a purpose, and that's kind of what I wanted to show you. So that's pretty much all I wanted to do tonight, was to just kind of give you some examples of some of these. That leaves you with 8, 10. Oh, I see. I put 25 in at the end, huh? Okay. I don't remember. I can leave 25 in at the end, because it's kind of a cool problem, but I don't know. I must have thought about something extra. But anyway, so 20 is like 21. And we'll see how 25 goes on Monday. So we have 8, 10, 20, and 25. So that's not very many for you to play around with, all right, as you do these. Questions on anything here, or questions on anything from the review that you might have saw that you want me to talk about, or anything in general? Okay, I'm double checking to make sure that this is good to go. Let me change this to 20. That was pretty close. All right. Sweet. Okay, so the only thing that we have left then is to do the quiz, and then that's it. So it should be available for you. Same format as last time. If you're comfortable with putting your answers right there in the detail on the quiz, you can. If you're not, and you just want to just work on it and email it to me, that's fine too. Just make sure you call it quiz 2. All right. And I should be able to try to get some of these things graded, so we have some ideas of where we are on Monday. So look for the review answers on Friday. And I'm going to stop the record here before I forget. And I will leave this